discussing the topics of synchronous machine. Last class, we discussed the excitation types, the curve, magnetization curve, the rotating flux, the power flow, and we stopped at this part here, the equivalent circuit of the machine.
دكتور ممكن بس تكبر السلايد ده؟
نفس المشكلة. Just a moment. Yeah. Now, شباب, regarding the machine, we have field winding, we have armature winding. The effect of field winding is just generating the flux, which will interact with the stator, and on the stator winding, we will have EMF. So we don't need to add the field winding in our circuit, just the excitation effect here, which is the exciting or generated voltage, EF, and then we have XS and RA, which are representing, RA representing the armature resistance, the armature winding resistance, and XS represents the synchronous reactance. Synchronous reactance is the summation of two main parts, the self and the mutual effect of the windings. Self, which is XL, and mutual due to armature reaction. So it's two parts. However, we will all of time we will interact only with XS. And in all problems, the synchronous reactance will be given, or we will use it in our problems. We are not going to use two parts of XS, just one part like that. So for now, the equivalent circuit, we have only source, AC source, representing the excitation voltage or generated voltage, and the armature resistance and leakage reactance or synchronous reactance. The voltage at the terminal of the machine is called V terminal. So these are the definitions. What we are going to use: X is synchronous reactance, RA armature resistance, VT is the terminal voltage, IA is the armature current. Now, Shabab, if the armature current is going out of the machine like that, is it going to be motor or generator operation?
Generator,
exactly. So the direction of current here now representing synchronous generator. So, if we would like to make Kirchhoff voltage loop here for this circuit, we can say that EF equals IA multiplied by RA plus JXS plus V terminal. So this is now representing the synchronous generator model. So EF equals V terminal plus IA-RA plus IA-JXS. طبعا IA is a vector, which means when we represent IA, we have to add magnitude and angle. The magnitude of current is the absolute value of current in ampere, RMS value, and the angle is the angle of power factor, which is the angle between the armature current and terminal voltage. This is representing the power factor angle. Okay يا شباب؟ طبعا XS, because it's inductance, so it's imaginary part, so we have to add J here, which represents 90 degrees. So this is now the relation, and the vector or resultant vector will be magnitude EF at angle delta. And we will call this angle, Shabab, as power angle. Power angle. Why it's power angle? Later, inshallah, we will see why we call it power angle. This is for generator. What will happen if it is motor, Shabab?
Current goes in.
Current will be reversed, صح? It will be entering to the machine. In this case, we can say now EF equals V terminal minus IA multiplied by RA plus JXS, which is this relation. And for this case, you will find that EF at angle minus delta. This is, inshallah, will be represented in phasor diagram. We will see that for all of cases of generator, delta is positive, and for all of cases of motor delta is negative. طيب.
Doctor.
تفضل.
This for self-exciting for self-excitations. This model.
Self. What do you mean by self-excitation?
Like this I mean, this model represents only like general synchronous machines, or like a specific kind.
Yeah. It's mathematical model for cylindrical type synchronous machine. Okay, you mean according to the type of excitation?
Yes.
Yeah, for all of types of excitation. Okay, either brush or brushless. Okay.
This is for cylinder type, am I right?
Cylindrical type, yes. Okay. If we now, if you would like to represent the phasor diagram of this equation, phasor diagram is very easy. You can represent phasor diagram simply, but you need to understand some basics. First, phasor diagram will represent voltage terms, not voltage and currents, which means this term is volt, the second term is volt as well, third term is volt, and we cannot say V plus I. We cannot add two vectors, different types. It has to be the same type, voltage vector or current vector. So all terms here are voltage vectors. All terms has direction. So V terminal, we will assume all of time, V terminal is the reference at angle 0. IARA will be a vector in the direction of the vector of current. So current is a vector. So the vector IARA will be another vector in the same direction of current. For IAJXS, it means another vector perpendicular to the direction of IA, because there is J here, which is plus 90 degrees. When we summate three terms like that, the resultant vector will start from the beginning of the first vector to the end of the last vector. So let's start together representing the phasor diagram of this equation. V terminal, this is V terminal. Assuming we have lagging current, so this is IA, lagging to V by angle theta, which is the power factor angle. So we expect to have the second vector should be started from the end of the first vector. So this is the end of the terminal. We can start plotting the second vector here. IARA will be another vector in the same direction of IA. So starting from the end of V and plotting another vector in parallel with IA, because it's in the same direction. So this is IARA now. Then IAJXS, which means J, which is 90 degrees, right angle on the vector of IA. So this is right angle on IA, and this is the magnitude of IAXS. So the summation of the three vectors will be the resultant one, EF. Is it clear يا شباب how we plot the phasor diagram? طيب. تفضل.
I was gonna ask about the angle of the current, like
yes,
from where do we get it?
We assumed lagging power factor in the beginning. Here, we assumed here lagging power factor. طبعا this is the شباب generator. Generator, it means the current will be lagging, leading, or unity according to the connected load. Okay. However, in synchronous machine, we can even control the power factor. We will understand when we discuss about the dynamics of the machine and the V curve of the machine, how we can control also the power factor of this machine. Type. Now, if the current is in phase with voltage like that, which means unity power factor, you will find that IARA will be in the same direction, GIAXS perpendicular like that, and this is EF. For leading power factor, IARA will be in parallel with the vector of IA, and this is GIAXS. and this is the resultant E. When we compare between the three phasor diagrams, what we can observe here يا شباب؟
The
leading.
lagging
is the same for EF.
EF is decreasing when the power factor moving from lagging to unity to lead. Is it right? EF is decreasing now. So we can say, or we can represent now, lagging power factor as over-excitation. Over-excitation, because EF is high. For unity power factor, we call it as normal excitation. Normal excitation. And leading power factor, we call it as under-excitation. So we have three different expressions for the excitation of synchronous machines: over-excitation, normal excitation, and under-excitation. All of time, over-excitation is in lagging power factor for generator. Okay, يا شباب, for generator, lagging power factor is attained for the case of over-excitation. Fine. Also, we can observe here, يا شباب, that the power angle delta is positive in the three cases. So we can say now the power angle is positive. It represents the flow of power. If the power angle is positive, this means the power is coming out from the machine. Because we will see in the motor, it will be reversed, it will be negative. This is the case of motor, يا شباب. In case of motor, this is our relation in motor. EF equal V thermal minus IARA minus JIAXS. When we represent, this is start with leading here, for instance, at leading power factor. So by the same way, this is V terminal. IARA will be in that direction, but it's here, it's minus. So it should be in the opposite of the current IA. So as you can see, it's plotted here in negative direction. Then JIAXS, J means 90 degrees in positive, and minus J means 90 degrees in negative. So we plotted J in negative like that, JIAXS. The resultant of the three vectors will be this vector. So this is EF. As you can see here, delta is negative. The same is also for unity power factor and lagging power factor. So we can say now, شباب, that delta represents the power flow. Is it going to be motoring or generating? If it is in minus sign, this represents the motor operation. And if it is in positive sign, this will represent the generating operation. Now, as you can see here, regarding over-excitation, under-excitation, and normal excitation, it's reversed compared to generator. Because here we have leading power factor at over-excitation. So over-excitation is leading with motor. However, under-excitation is lagging with motor. In order to memorize that, we can just write these three words: over, generator, lagging. Just these three words. Over-excitation for generator is lagging. If you would like to change these words, you can change only 2 out of 3, or you have to change 2 out of 3. So if I said to you the under-excitation in generator, what will be the power factor?
Leading.
Exactly. So the under-excitation with motor what will be the power factor?
Lagging.
Lagging.
Exactly. يعني this will يعني save time for you because يعني instead of plotting phasor diagram يعني if you have MCQ for instance in the exam, just memorize these 3 words, you can expect the third one, okay, or the requirement يعني instead of plotting phasor diagram from scratch يعني it takes time. طيب. So these are يا شباب تفضل.
دكتور we draw the phasor diagram just to compare these 3 cases.
Phasor diagram is very important for all of cases. يعني we can ask you to plot it in phasor diagram in the exam, just like that, just what we have drawn here, or it can be drawn according to the example. In examples or problems, you can draw the phasor diagram for certain operation. So you have to understand how to draw phasor diagram. It's very important. Okay, it's not only to drive or to observe some notes here. It's very important to drive or to draw, to know how to draw phasor diagram for all of cases. It's just mathematical representation. Huh? Yani we just, if you know the basics, how to draw phasor diagram, you can draw phasor diagram for any case. Okay, so you have to plot it يعني by yourself. يعني don't only يعني have a look on the phasor diagram like that. لا, you have to train yourself. Start plotting the phasor diagram, and if you have any problem, يعني you can ask. Okay? يعني it's very important يا شباب. يعني this is very important for our course. Don't read only slides. You have to write everything. You have to write your equations. You have to write the solved examples. Even solved example, you should write it outside and solve the problem yourself. Otherwise, in the exam, you will not be able to write. You train yourself, and when you write the solution, you can write it on the exam. However, if you only read the slides and the examples, this is not enough. You will come in the exam, cannot write anything. يعني this is يعني سبحان الله يعني يا شباب دي حاجة يعني عند ربنا يعني زي ما بتعمل تدريب للعقل العقل بيعمل. لو هتدرب نفسك فقط على القراءة يعني هتيجي في الامتحان مش هتقدر تكتب. يعني you have to train yourself. ماشي؟ طيب.
Doctor, someone raised his hand.
Sorry, Doctor,
تفضل.
I have a question.
تفضل.
I wanted to ask, is the voltage terminal rated voltage?
Yes, this is very important question. Now, the generator يا شباب, the terminal voltage of the generator, it should be rated all of time, and even the motor. تمام? And we will discuss now the connection of synchronous generator to grid. The voltage has to be constant. This is very important. This is rated voltage. For that, شباب, we will assume that V terminal all of time fixed value at 0 angle. Okay? However, EF will be changed according to our control. We can control the excitation voltage by means of field current. And we will discuss this, inshallah, maybe in the next two slides or like that.
Doctor.
تفضل.
But what's the use for like phasor diagram for us, as engineers?
Sorry, your question again, please.
The use of phasor diagram, like what's the benefit of knowing it?
To understand the case of your operation, because the phasor diagrams will not be only like that. You will have many cases. You can use phasor diagram to solve the problem. Okay, يعني it's not important to solve the problem analytically. You can solve it graphically using phasor diagram. In this case, you have to make scale and start solving using phasor diagram. Some problems we cannot solve it analytically, or يعني if we use phasor diagram, it will be much easier. Okay, so you have to understand how to plot the phasor diagram. It's very important.
Okay.
Sorry, Doctor, I have other question. For the IA, how can we come up with the current, this current? Is it rated current or? How can we measure it, or we should measure it by?
لا يعني and now we did not discuss how we can get the values from examples yet. يعني we will see in examples يعني everything will be clear. However, now we just need to represent the equation. We just now representing the equation to get up the observations of over excitation on under excitation, normal excitation. What's the meaning of unity power factor, lagging, leading? This is the what we need here from plotting phasor diagram. However, in problems, everything will be clear. You will have the value of current, you will have the power factor, and you can draw the phasor diagram easily to scale. Okay?
But that the current will depend on the load, am I right?
For the synchronous generator, yes, it's load dependent. For synchronous motor, it will be different because we can control the power factor according to the excitation.
In the synchronous motor, can we control the power factor?
Yes, we will control the power factor.
Or it will be set by the manufacturer?
لا, you can control it. You can control it.
Okay. Thank you.
I have question يا شباب. هو انتوا نسيتوا الكورس بتاع 360 ولا ما خدتوش الكلام ده في 360؟
We did take it like we did take it like a few, like a quick glance or something.
Okay, but not in details يعني.
Small details, I would say. Like, I don't know if this course is gonna go with deep details about it, or there's something to do and learn, but we didn't learn like how to draw it, like, you know.
Yeah, okay, no problem. And for that يعني I ask because it's very important, because sometimes I may skip some parts يعني to go in something advanced. However, if you did not يعني take it before, I have to discuss everything in detail. طيب, okay. طيب, now يا شباب, let me give you an example before of starting in the parallel operation of synchronous machines. If we have a table, a big table, this big table with a dimension, for instance, 4 meters by 2 meters, the area of 4 meters by 2 meters. So this table, is it easier to be carried by one person or 2 or maybe 5? What do you think?
Can you repeat the question?
Again, if we have a big table, 4 meters by 2 meters, okay, is it easier to be carried by one person or many persons, 5 persons, for instance?
Yes, the more the better.
Okay, so if we have only 2 persons carrying this table, what will happen if accidentally one of them is fell on the ground? What will happen to the table?
It will collapse.
Exactly, it will collapse. So the benefit, if we have many persons carrying the table, if one of them is held on the ground, the others can carry the table safely. Is it right, Shabab?
Yes.
The same is for the parallel operation or for the connecting generators to grid. For all of grid, Shabab, electrical grid, all of power plants are connecting their synchronous generator to grid. يعني, for instance, if we have a power plant here in Dammam, this power plant will not only supply the region of Dammam, it will be connected to the grid. It will supply the region of Dammam. However, it has to be connected to the grid, which means it can supply another load in Jubail or in Ihsa, which means all of power generators are connected together on the same grid. What is the reason? The reason is to increase the stability of the power system, stability of the grid. And another reason is to improve the reliability of the system. Reliability means our system is reliable enough which means if one of them is failed to work, others can work and carrying the load. So we have some economical aspects. Okay, so for economic operation, we need to connect generators to infinite bus. We need to connect generator to the network, and also for reliability and stability of the power grid. So the advantages of having synchronous generators operating in parallel are economic operation. Economic, it means we may have one of generators working at certain rate, and it consumes little fuel compared to the other one. So we can now make like energy management between the two parallel generators in order to select the one which will give us a lower consumption. So for economic operation, economic aspect, it's very important to operate generators in parallel, and also for reliability as well as stability improvement of the power grid. Like how we can connect generators in parallel, شباب. Now, if we can imagine, this is the sinusoidal waveform of the generator, and assume we have another sinusoidal waveform for the grid. How we can connect these sources in parallel, or what are the conditions to connect these sources in parallel, شباب?
Should be identical.
Exactly. The two sinusoidal should be identical and should start from the same point. So, يعني both of them have to be on the top of each other, صح? Both of the waveforms has to be on the top of each other to be connected in parallel. This means if the two sinusoidal waves are identical, this means they should have the same RMS value of volt, the same frequency, and the same phase shift. يعني they should start from the same point. صح يا شباب? If we have two waveforms identical and started from the same point, this will reflect the three conditions: same voltage, same frequency, same phase shift. Phase sequence, it means if we have three-phase systems, it means phase A from generator side should be connected to phase A from the grid. The same is for phase B and phase C, which means we have ABC sequence and the ACB sequence. So if the grid is ABC, the generator has to be ABC as well in order to be connected to the grid. So these are, شباب, called the synchronous or synchronization conditions. Synchronization conditions. Again, same voltage means the same RMS value of volt, same frequency, same phase sequence, and the same phase shift. We have, inshallah, one experiment regarding the synchronization of synchronous machine. We will discuss it in the next week, inshallah. This is our experiment, how we can make the synchronization. As you can see, if we have grid which is represented by generator A here, okay, and we can call it, شباب, as infinite bus. Infinite bus means fixed or rigid voltage. Voltage is constant and frequency is constant as well, cannot be changed. And now we need to connect this generator B in parallel to the grid or in parallel to generator A. How we can do that? Simply, we can check the voltage drop between the two terminals around the switch here. We will add a switch, and this switch here can be connected if the generator B is synchronized with the infinite bus. We will connect three lamps like that around the switch's terminals, and if the 3 lamps are turned off completely, we can turn off the switch, because if the 3 lamps are completely turned off, this means the instantaneous value or the instantaneous voltage difference between grid and generator is 0. And this cannot be happened if one of the conditions are not fulfilled. Any of the conditions, if one of the condition is not fulfilled, we cannot find the lamps off. So if the lamps are completely off, this means the 3 poles of the switches have 0 difference volt, which means the 2 waveforms for the 3 phases are identical. And in this case, we can connect this switch on. Actually, it's not that easy, because we have to fulfill the 4 conditions, but we can do it in laboratory. Okay, and if the lamps are completely off, we will turn off the or we will connect the switch. And if we connect the switch to the grid, in this case, we can say the generator is now connected to the grid. By the way, Shabab, if the generator is work without connection to grid, we call it as independent generator. Independent, it means it's work alone without the connection to grid. However, if it is connected to grid, we call it as dependent generator type. As you can see here, Shabab, if we have A capital and A small like that, A capital, as you can see here, for instance, A capital is the generator terminals and A small is the grid terminals. Okay, so if EA, or the voltage of phase A, is not the same as the voltage of phase A of the generator, which means we have a voltage drop of E capital, A capital, A small, which means there is a voltage drop. In this case, we cannot connect the generator to grid. We can only connect if this voltage drop is 0, which means the 2 vectors are equal. Tamam? Type. These are representing the phasor diagram for all of the unfulfilled conditions. For instance, first case here, assume this is a capital of generator and this is small letters for the grid. We have here 3 vectors for the generator or grid, and these 3 vectors for the generator at instant t1. Okay, and in case of f1 different to f2, not equal, this means that after certain time at t2, you will have a phase shift between phase A of the generator and the grid. يعني it will be like that يا شباب. تمام? So if the frequency is not equal, as you can see, the voltage will be there will be a voltage between the 2 phases of the grid and generator. So we cannot connect. So this here represent the frequency condition is not achieved. Type. For this shape here in shape D, as you can see here, F is the same, and the magnitude of E small and A capital and A small are almost equal. However, due to a phase shift between the 2 vectors, there is a voltage drop. So this means here there is a difference in phase shift, so we cannot connect. Here, there is a difference in phase shift and the phase sequence as well. As you can see, there is a phase shift between A capital and A small. However, you will find for the grid, small letters, A, C, B. So the sequence is A, C, B. However, the other is A, B, C. So the sequence here is different, along with a small phase shift between the two phases as well. So this is شباب representing the different cases which are not fulfilled. However, how will be the shape if the four conditions are achieved? You will have the two sets of phasor diagram on the top of each other and moving in the same speed. This means the two sources are connected in parallel and synchronized. Fine.
Sorry, Doctor, I have a question. Regarding this condition, actually, is the phase shift same as the unequal of the frequencies? If we have different frequencies, that means we have different phase shift. Am I right?
If you have different frequency, it means sometimes there will be starting from the same point and then it will have a phase shift after that, because one is faster than the other. تمام?
But this is different than the phase shift.
It's different to the condition of phase shift, yes.
Honestly, it's not clear for me.
It's not clear. Type. Let me give you an example. If you have two persons, one is moving with a speed of, for instance, or running 10 meters per second, and the other is moving in 8 meters per second. Okay? This means if they start from the beginning together, and they are moving in a rotation, okay, moving in a circle, okay, this means this one is faster than that one, صح؟ مظبوط؟
Yes.
However, due to the rotation, he will go faster and return back again and meet him again, صح ولا غلط؟
Yes, you're right.
Type. This is the same as the different frequency. So if they started from the same point, there will be a shift between them all of time, and when he run and return the cycle again, he will meet him again. At the instant of meeting him again, the phase shift will be zero. صح ولا غلط?
Yeah, yes.
Yeah, this is the difference between, or this is now the condition of case of the different frequency. Now, if we have different phase shift but equal frequency, what it means? It means we have two persons moving in the same speed. However, one started before the other by certain time. So they will move in the same speed and will keep the same value of phase shift all of the time.
Clear, yeah.
Is it clear now?
Yes. And why we put this condition for the phase sequence?
We put this condition because it happened in our grid. If you would like to connect the generators together, if we said only voltage, frequency, and sequence, you have frequency meter. You can find the frequency of generator and the frequency of grid similar values, 50 or 60 hertz together. Okay, and you can find that the line voltage of the generator here equals to the line voltage of the grid. And also we have a relay that can interact with the phase sequence, so we can recognize the phase sequence as well, ABC here and ABC there. These three conditions are not sufficient to connect the generator because we still have one missed condition, which is the phase shift.
Yes.
So the three conditions are not sufficient. So we have to fulfill four conditions together. طبعا عمليا يا شباب, there is a device called Synchronous. This device is making the synchronization condition automatically. However, طبعا in our lab we will make it manually, like using these lamps and switch like that. But how we can change the values? This is what we are going to describe in detail, inshallah, in the experiment. Okay.
Sorry, I have the last question, inshallah. My question is that What will happen if there are the two generators are not synchronized, not
And you
identical?
connect them together.
Yes.
It's similar to the short circuit. Now, if you have a wire and you put this wire on the socket to make a short circuit in the socket, there's a voltage difference between the wire is 0 volt because it's short circuit, and the socket is 220 for instance. 0 and 220 connected in parallel, it's short circuit. The same is also here. If you have any voltage difference between two values and you connect them in parallel, it will make a short circuit.
Oh.
Okay.
Okay.
So this is the reason يا شباب دايما يا شباب for all of AC supplies, if you would like to connect two AC supplies together, you have to fulfill the 4 conditions. In DC supplies, we have only one condition because there is no frequency, there is no rotation, it's only one magnitude. If the two batteries are similar in magnitude, you can easily connect them in parallel. However, in AC, you have to fulfill the 4 conditions. طبعا if it is only single phase, there is the phase sequence will not be one of the A conditions because it's only single phase. So you have to fulfill the 3 conditions. Okay.
Sorry, doctor. The 4 conditions are the frequency and phase shift and the
voltage,
phase sequence and the voltage.
Yes, exactly. Voltage,
Thank
frequency,
you,
phase shift, phase sequence. Yeah.
okay. Thank you, doctor.
Welcome. طيب بالنسبة شباب يعني regarding the determination of synchronous reactance يعني it's يعني discussed I believe in detail in the course of EE360. يعني I believe I added here just for your information. However, we can skip this part, determination of synchronous reactance. يعني it's a very easy part, and I believe also you had it as an experiment. Is it right? Did you make it an experiment, شباب, in EE360?
Yes, we did. Yes.
Okay. So يعني I believe يعني no need to go in this in details. يعني for any generator يا شباب, if we need to determine the parameters of generator, we have some tests to be done. One of the tests here is called open circuit and short circuit test. It's similar to the transformer. So we can easily obtain the parameter using the open circuit test. And the parameters is nothing but the synchronous reactance because it's a very important part. However, yani we will skip this part, but it's given for you if you would like to read it and you have any question, yani we can discuss it together. However, it's not important to yani for our exam, inshallah. Type. One of the important things we will need, shabab, in our problems is the per unit calculations. Do you know the meaning of per unit calculations?
Yes, we use
For me,
most
yes.
of the time.
Good. Fine. I will just give small hints about per unit calculations. In order to make per unit calculations, we need to firstly obtain the base values. How we can get the base values, shabab? We need 2 things for base values. First, all base values has to be phase. So firstly, we will get the base value as phase value. This way will be very simple. So firstly, you can say S base, which is the apparent power, equal S 3-phase rated value over 3. Base value is the rated. Okay, base value all of time is the rated value. تمام? So S 3-phase over 3. This will represent the base value of power. Number 2, base values are only vectors, which means we have S base, but we don't have P or Q base. So if you would like to calculate P in per unit, we can say it's equal to B actual value over S base. So there is nothing called B base or Q base, تمام يا شباب? Because base value will be vector all of time, and B and the Q are not vectors. B and the Q are real and the imaginary parts of the vector. So These are the two important notes when we solve problems in per unit. Also, for the star connection, if we would like to get the base value, firstly we will say V base equal V rated line over square root of 3. طبعا يا شباب, for all of three phase systems, the given value is line to line. All of time, for three phase systems, all of values are given as line to line. So if the connection is star, the value of phase volt will be V over square root of 3. Right. What's after getting S base and V base? Now we can start calculating everything. I base equal S base over V base. Z base equal V base over I base, which is equal to, we can replace I base by S base over V base. So it will be V base square over S base. So for any value we need to get the per unit, we can say per unit value equals actual value over the base value. This is the solved example regarding the parameter calculations, and we will skip it as well.
Doctor,
تفضل.
is the drawing of the characteristic is important in this example?
Drawing characteristic is related to the example, so يعني I will not bring it to you in the exam. يعني it's just for your knowledge. يعني if you would like to read, and you can read, and if you have any question you can ask, but you don't need it in the exam. So solve example 1 يا شباب, يعني we can يعني neglect it from our course. But يعني again, if you would like to read, if you have any question regarding it, يعني you can ask. Fine. This is because we have many يعني topics we need to cover in our course, and I believe it's not covered in previous courses. طيب, regarding the power and torque يا شباب, this is the final part of today. Regarding the power and torque characteristic of the synchronous machine, we can start the revision of power from scratch. You know S equals V multiplied by I conjugate. This is in per unit يا شباب, okay? So or per phase, so we will not multiply by 3. However, for 3 phase you should multiply here by 3. But let us now يعني make the revision based on per phase calculation. So S equals V. I believe the time is due now. لا خلاص كده يبقى إن شاء الله يعني we can continue in this slide إن شاء الله next class, because it's 11:50 now. طيب. Any question يا شباب؟ تفضل.
Yes, doctor. S represent what?
S represent apparent power.
Apparent power.
Yes.